Hello friends, welcome to engineering tutorial. So in today's video we are going to take up some problems related to calculation of equivalent capacitance. So far we have discussed about equivalent resistance calculation, equivalent inductance calculation, and we have discussed around 3 to 4 videos related to each concept. So now today we are going to discuss about equivalent capacitance calculation. Okay, so we are going to start with a simple question first, as we did in resistors and inductors case, and then we will gradually discuss more and more complicated or complex circuitries. Okay, so this is a circuit. Okay, you can see there are total 4 capacitors of values 2 microfarad, 3 having values 2 microfarad and 1 of 1 microfarad, which are connected in the given way. So we have to find out the equivalent capacitance between these 2 points A and B. So similar to resistors and inductors, the approach is the same. First we have to identify the group of capacitors which are connected in a certain way, and then we reduce it into a simpler form, and then we gradually go on reducing this circuit into a single capacitance, which is the equivalent capacitance. Now you can see in this circuit, this 2 microfarad and this 2 microfarad, they are connected in series. Okay, they are connected in series. These two capacitors having values 2 microfarad and 2 microfarad, they are connected in series. So we can find out the equivalent capacitance of this combination. Okay, so this is equal to C equivalent is equal to 2 microfarad plus 2 microfarad. Now if you write this as this, simply add the two values and tell that the equivalent capacitance is equal to 4 microfarad. It means the equivalent capacitance of this combination is 4 microfarad, then it is wrong. Now here is where most of the beginner students, they make mistake. Okay, now in case of resistors and inductors, whenever two resistors or a number of resistors or number of inductors are connected in series, the equivalent resistance or the equivalent inductance is simply the addition or the summation of the individual resistances or inductances. But in case of capacitance, it is the opposite. Whenever two capacitors are connected in series, okay, end to end connection, okay, one end, one extreme end or right end is connected to the left end, means there is an end to end connection pattern. The equivalent capacitance is actually the sum of the reciprocal. Okay, so here if the equivalent capacitance is C equivalent, it will be 1 by C equivalent is equal to 1 by C1 plus 1 by C2. This is correct. So it will be 1 by 2 plus 1 by 2, which is simply 1 microfarad. So if you write it as 4 microfarad, means it is just simply add them, it will be wrong, because most of the time they confuse that the resistors, inductors and capacitors, they follow the same formula whenever it comes to series and parallel connection, then it is wrong. Only resistors and inductors have similar formula related to series and parallel connection. In case of capacitors, it is the opposite. Okay, so the correct value is this 1 microfarad. 1 by C equivalent is equal to 1 by C1 plus 1 by C2, which is 1 microfarad. Now the equivalent capacitance of this combination of two capacitors is 1 microfarad. Now this 2 microfarad and this 1 microfarad, they are in parallel. This is 1 microfarad. Now these two capacitors, 2 microfarad and 1 microfarad, they are in parallel. So the equivalent capacitance of this combination will be simply the summation 2 microfarad plus 1 microfarad. See, this is opposite to that of the formula of equivalent capacitance of parallelly connected resistors and inductors. I have already posted a video related to the concept of equivalent resistance, capacitance and inductance, the formula and their mathematical derivation. I have posted it in my channel, so please check out those videos. You will find this things a little bit easy. So this equivalent capacitance of this combination is 3 microfarad. Okay, this is 3 microfarad. Now we further simplify the circuit. So we replace it with its equivalent capacitance, that is 3 microfarad and 1 microfarad. Now this 3 microfarad and 1 microfarad, they are in series. So the equivalent capacitance of this combination will be 1 by C equivalent is equal to 1 by 3 plus 1, which is equal to 4 by 3. This is 1 by C equivalent. So C equivalent, 1 by C equivalent is 4 by 3. So C equivalent will be 3 by 4 microfarad. C equivalent is equal to 3 by 4 microfarad. So always take care that in case of capacitors, the series and parallel equivalent formula is simply the opposite of that used in resistors and inductors. When capacitors are connected in parallel, let us say C1 and C2, the equivalent capacitance will be the addition C1 plus C2, let us say up to nth. There are n capacitors which are connected in parallel, and when they are connected in series, okay, let us say this is C1, this is C2 up to nth capacitor, then the equivalent capacitance will be like 1 by C equivalent is equal to 1 by C1 plus 1 by C2 dot 1 by Cn. So it is the opposite of that of the formula of equivalent resistance and equivalent inductance. So always be careful about this. Don't by mistake use the same formula. You will think that the answer is correct, but actually it is wrong. So always be careful about that. So this is a simple and basic problem which is related to calculation of equivalent capacitance, and then we will discuss some more problems which involves a lot of capacitors which are connected in tricky ways, and we'll solve that. Okay.